Okay, you guys, in this section, we're solving polynomial and rational inequalities. That's the goal, so let's get to it. So in this first example, we're going to solve 3x squared minus 4x is less than or equal to 4. This is a quadratic inequality. Does everybody see why? If it were an equal sign instead of a less than or equal to, it'd be a quadratic equation, wouldn't it? So you put in an inequality instead of an equal sign, it becomes a quadratic inequality. The technique you use to solve this looks like the technique I presented to you for solving absolute value inequalities, if you remember that video. The first step, you're going to solve the related equation. It's the same first step as when you solved absolute value inequalities. It'll be convenient in the end to get 0 on one side first. So I'm going to subtract 4 from both sides and get 0 on one side. So we have 3x squared minus 4x minus 4 is less than or equal to 0. And you could do that right now or later, doesn't matter. That should say related equation. And so I'm going to change this less than or equal to an equal sign. 3x squared minus 4x minus 4 equals 0. And this is going to give you what I called in the absolute value inequality section the critical values. What method would you like to use to try to solve that? Here's a hint. There's a left parenthesis. So how about we unfoil it? So 3 and 1, 3x and 1x. And then what else? You want to try 2 and 2? And then one of them's got to be minus, right? Which one? The second one, x minus 2. Okay, let's make sure. If you multiply out the outer together, what do you get? Minus 6x, the inner, plus 2x, and if you add them, you get minus 4x. So that works. Set both factors equal to 0. Do you see how you start using the skills that you used for smaller, shorter problems within the context of this bigger problem now? Solving a quadratic equation by factoring is just one part of a bigger problem now. We set both factors equal to 0 and solve. What do we get for the left hand one? 3x plus 2 equals 0. X equals negative 2/3 or x equals 2. So these are called critical values. These are the values that make 3x squared minus 4x minus 4 equal to 0, right? And remember, we make a number line and we put those critical values on the number line. Okay? We can do that. Make a number line. Put in a couple of scale marks, negative 2/3 on one side, left side, and 2 on the right. And then these create borders. So the idea then is once you graph those critical values and realize that your possible intervals of solution go from negative infinity to negative 2/3, from negative 2/3 to 2, and from 2 to infinity. The next thing to do is just to determine which of those subintervals satisfy the inequality by using test points, or test values if you like. Okay, so what test value would you like to pick in here? Negative infinity to negative 2/3? Yeah, let's not get too creative here. How about negative 1? Something easy to work with. Okay, so if your test value, that's an x value, right, is negative 1, well, okay, where do you want to put that? Well, look, if you look at the factored form of this guy, we know it factors to be 3x plus 2 times x minus 2. Look at the factored form of the inequality. It would be easiest to plug the negative 1 into that. I'll show you why. Look, if you plug a -1 right here in for x, you don't even need to determine what the actual number is. Since it's factored, all you really need to know is whether or not it's positive or negative. So if you take 3 times a -1, that's -3, plus 2, are you going to get a negative or a positive number? -1, right? Negative. All I really care is that this factor, when you plug in -1, this factor is negative. Does everybody see that? So I'm not even going to put what the number is. I'm just going to put that it's negative. Does that make sense? Now, what happens when I plug in a -1 in the second factor? It's -3, but that, who cares? The exact number doesn't matter. It's the fact that it's negative that matters. Does everybody see that? And then since it's in factored form, what you're really doing is you're taking a negative times a negative. Is that going to be less than or equal to 0? Question mark. Big old no. You got the test value of -1 from the interval -infinity to -2/3. As goes the test value, so goes the entire interval. So that entire interval will not satisfy, any number from that interval will not satisfy the inequality. So you put in a big old no right here. No. No! You can shout, no! Entertain yourself, you know, be goofy. Be goofy. Let's try a test value in between -2/3 and 2. So let's try a test value of, make your life easy, 0. That's a number between -2/3 and 2, so a test value of 0. Well, if you're smart, you don't have to plug into the factored form in this one since you're plugging in 0. You could plug into the original form, or even better, this form, right? Isn't it super duper easy to plug in 0 right here? What do you get? You get a -4 is less than 0. Is that a true statement? Yes. You could be happy. Yes. All right. Now, usually it does alternate, but not always. So you do have to test each interval. So what would be a good test value from the right-hand interval, 2 to infinity? 3. If it's non-zero, it's best to plug in the factored form. Erase some of my parentheses. If it's non-zero, it's best to plug in the factored form. If your test value is non-zero, plug the 3 in right here. You just need to know whether or not it's positive. 3 times 3 plus 2, is that positive or negative? Positive. A test value of, what did we say, 3. Test value of 3, we'll plug it in right there. Try again. Plug it in right here. Trying to make some room here. Let me scoot this guy over a little bit. Okay, test value of 3. Okay, we plug a 3 in here. You guys told me, oh, that first factor is positive, right? If you plug a 3 in here, this guy's positive. What about this guy? Is it positive or negative if you plug in a 3? Okay, is a positive times a positive, is that less than or equal to 0? Not last time I checked. So question mark, is that less than 0? No! You can get mad at it. No! Your roommate or your mom or your dad will wonder what you're yelling at. It'll be entertaining. Just, God, she's in her room alone shouting no. What does that mean? And then you can laugh at them and say, oh, no, I was just doing math. Okay, so where are you going to shade here? The middle. So we'll shade right there. Now, are the endpoints going to be included here? How do you know? Because of the or equal to part, the endpoints are included. So you could either use brackets or closed circles. And you got your solution. You just have to write that number line graph in interval notation. So what's the solution interval? -2/3, comma, in a bracket, comma, 2. There you go. What we're saying is all the x values or input values between -2/3 and 2 will satisfy that original inequality. Okay? That's it. That's what it means.